Now we look at another very important molecule in the body, and this is what is known as glucose 6 phosphate. So glucose 6 phosphate, this is it. And one thing I always like glucose 6 phosphate is well, in the carbohydrate pathway we have it, and also in red blood cell metabolism we also have glucose 6 phosphate actively working there. So let's look at it on a general note. Do you understand? And also state its importance. So just so you know, it's a central molecule. Okay? So it's a central molecule. It acts as a crossroad for multiple, metabolic pathways. So what is it? It's a type of molecule. It's a phosphorylated sugar. That means what? You have glucose. So you're adding sugar, that's phosphate to it at position 6. That's why it is becoming glucose 6 phosphate. So it's produced when glucose enters the cells and is now phosphorylated. It enters the cell, then phosphate is now added to it. Function, it traps glucose inside the cell. Okay, phosphorylation prevents it from freely leaving. Okay, so this is it. Glucose hexokinase adds what? Phosphate to it. It becomes what? Glucose 6 phosphate. So, like metabolic roles, glycolysis can be converted to fructose 6 phosphate, entering the glycolytic pathways. Glycogenesis can be directed towards what? Glycogen synthesis. Pentose phosphate pathways can provide NADPH, and ribose 5 phosphate, for nucleotide synthesis. Then also gluconeogenesis. In the liver, it can be converted back to glucose. Do you understand? By an enzyme known as what? Glucose 6 phosphatase. Then it will now be released back into the blood. Do you understand? So you have glucose again. So this is just this molecule on the general. So key enzymes that are involved with hexokinase or glucokinase will convert glucose, add phosphate to it at position 6, it becomes a glucose 6 phosphate. Then phosphoglucose isomerase will convert this into fructose 6 phosphate. Then glucose 6 phosphatase can convert it back into glucose. Then also glucose 6 phosphate dehydrogenase can convert it into what? 6 phosphogluconolactone. Okay. So we studied because you can have the deficiency of it, which can lead to a lot of red blood cells be getting destroyed before their time, which is the cause of anemia. Then also in glycogen storage disease, where sometimes you have glucose 6 phosphate, but the enzymes that are supposed to act on it are deficient. So it can be accumulating abnormally. Then also in diabetes. Okay. So this is what we have as regards glucose 6 phosphate.